Susie Cream Cheese is wearing tennis shoes with an effective surface area of 60 centimeters squared. While wearing these, she exerts a pressure of 89 kilopascals while supporting her weight on one foot. So she changes for a night out into stilettos with a surface area of only 10 centimeters squared. So how much pressure does this shoe exert when she's only supported by one heel? All right, well, we know that pressure is just force divided by area. To begin the problem, we know the pressure that she's exerting on the ground, and we know the area, but that's not helpful. I need it in terms of meters squared. So let's do a quick little unit conversion. Because the unit is squared, it's not going to be good enough to just do one conversion factor of centimeters to meters. With centimeters squared, I've got to do it twice over. So I've got 2 instances of centimeters in the bottom. It cancels with the 2 instances of centimeters at the top, the 60 centimeters squared. And I'm left with meters times meters. That's meters squared. That's exactly what I want, and that's beautiful. So this area converts down to 0.006 meters squared. And I'll do that again, that's my initial area. I'll do that again for my final area. In just kind of a similar vein, 10 centimeters squared turns into 0.001 meters squared. All right, cool. So again, I start with pressure equals force divided by area. I now know the pressure in pascals, that's 89,000. And I know the area of her shoe at first in terms of meters squared. It's 0.006 meters squared. So let's solve for the force that she's exerting on the ground. Well, that's just going to be pressure times area, and that'll turn into 89,000 pascals times 0.006 meters squared. That gets me a force of 534 newtons. Now, this is a downward force she's exerting on the ground because of gravity's pull on her. So that force is going to stay constant, no matter if she changes shoes or not. She doesn't change her weight by changing her shoes. If only the world were that simple. So I can plug it just back into the force, the pressure equation, except this time I know the force, the 534 newtons, and I know the area is now 0.001 meters squared after she changes shoes. All right, sweet. So that gets me a pressure of 534,000 pascals, or 534 kilopascals. So just by changing shoes, she went from 89 kilopascals to 534 kilopascals. And that's why high heels often sink into the ground, or if you're not careful on tile, can even crack a tile floor.